Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam, Syed.
Can you see my screen, class?
Yes, sir.
Alright. Today we are going to continue with the decision logic structure, part 2. So hopefully by the end of this week, so you all is going to be ready for your midterm test on Monday next week. Okay. Okay, quick recap. What we already covered is, okay, on decision logic structure is, okay, over here. So let's look at the conclusion of last week class. So what we already covered is, ni. Jumpa pula. Okay, we already covered the case logic structure. Okay, case logic structure. Okay, where if you still remember, okay, case logic structure is similar with normal if else if statement kan. However, if we have multi selection, the only we are only using one single diamond, okay, in the case logic structure, okay. But not all decision can be implemented by using case logic structure kan. The one that we can only apply if in a condition involving integer or single character, single character only inside of the decision kan. If the decision involving floating point number or a string, so we cannot use case logic structure. So if that is the case, you need to apply normal if-else statement. Okay, for if-else statement, what we already discussed last week, consists of three types. Three types of if-else statement kan. So the first one is single selection. Okay, on single selection, if the condition is true, there's only a statement for true lah. If the condition is false, no statements at all. No statement at all kan. So the algorithm is going to be if condition is true, then there's a statement and no else. No else kan. No else if it is a single selection. Okay, so compared to by selection, the difference between by and single is there's a condition for both branches kan. True, there's a statement, and for the false also statement. And for the by selection, we are only using single diamond kan. So this is a by kan. So when we convert it into algorithm, we have if condition. If this is true, then this is a statement, and we have else. This is a statement. Okay, this is a statement for else, which is If it is a false, then there's a statement. This one is a statement. And then we have multi-selection. Okay, multi-selection. We have multi-selection. Okay, multi-selection. It's not here kan? I already updated. I already showed you the multi-selection kan? It's not over here. But with multi-selection, we have more than one diamond symbol. Okay. So what we are going to discuss is further today is on the multi-selection actually. Okay. Multi-selection. Okay, part 2 ni kan. Multi-selection. Okay, however, before that, okay, before we discuss further on the multi-selection, okay, this is what we are going to, the highlight of the topic for today, straight through logic, positive logic, and negative logic. Okay, these three logics. Okay, this is all about multi-selection and using if-else statement. Okay, if-else statement. But before that, let's look at the the answer of last week exercise. Lab exercise. Muhammad Naim, are you here, Muhammad Naim? Muhammad Naim ada, Muhammad Naim? Muhammad Naim? Ada tak? Muhammad Naim. Tak ada Sen. Okey, Muhammad Irfan. Muhammad Irfan.
Ada sir.
Okey, Muhammad Irfan. This is just a simple exercise. Before the end of the class today, I will give you exercise on previous midterm test question. So you are going to see the real question. Okay. Siapa ni tadi? Okay, given data, okay, the PAC, okay, clear. So supposedly the given data is the input kan. So there are two ways to write down given data kan, as we discussed kan. So either you put down the condition in the processing required, okay, like example like example like this okay, you put it over here, or you may also put it in the given data in the form of table. For example, over here is another way to write down the PAC. Okay, we put the decision in the given data. If you have a table, just copy and paste the table over here in the given data. Then it is accepted. Okay. Mana tadi? Ni So what is the input, class? The input is the total volume kan. So you got it correct over here. However, this is fine kan. Why you put fine over here? Any reason why you put fine over here? Ini Naim
Irfan sir.
Apa nama tadi? Irfan
Ya, Irfan.
Irfan, okay. Irfan fine Okay, why do you put fine over here? The reason?
Dia tulis find is the user input sir.
Okay,
Table.
alright. Okay, this is clear kan? So meaning that a user need to enter the total fine kan? So it is not given in the question. So you need to enter it in the form of input. So you need to know which one is the input. This one is clear. Sometimes it doesn't mention that this is the input, but you need to figure out which one is the input. So this is clear. Right, and then the required result. Okay, the required results. Where do you get this information? Irfan?
Yang the suitable clear yang the equation so formula to calculate.
This one, eh?
Uh,
Is there mentioned anywhere in the question what should be the outputs? Ada tak? It doesn't mention specifically. So you can go to minimum. The minimum, this is the minimum lah. Minimum for the output. One kan. Otherwise, sometimes question mention you need to also user need to also be able to display the earlier inputs. So you need to get this and put it over here as well. If the question mention like that. But if no, then you can go to minimum output. One, at least one. Okay, processing required. This is correct, is it? Correct? Based on this one, 1000 ml or less. This is actually clear. It is including 1000. Including. So you should use this. Less than or equal. Equal. Meaning that 1000 ml also included. So this is correct. And the calculation also correct. Calculation. Betul lah kan calculation 0.1. Okay, 0.1. Okay. Okay, define as user input value. Okay, for this one, make sure you put down all the inputs. Define the fine and total volume kan.
kiranya dia kena bubuh dua-dua input lah. Kau semua input yang ada asal.
Apa sih all the inputs
Okay.
Okay. Input value and just repeat it again kan. Repeat again. As apa? As a constant kan. This is minimum that you can do kan. Put one as input value, one as a constant, and you put star in front of the input value. Meaning that we choose this solution alternative instead of as a constant. So this is minimum that you can do. Alright. And then, okay, so this is clear. This is given given to you kan. Okay. Let's say if this one put read calculate, for example, this one calculate discount given to you given to you this figure. So make sure you don't put calculate over here. Make sure you put calculate discount lah. You must follow the given IC. Okay. Let's say if this is the case, and you need to follow. Boleh Okay. Alright. So okay. IPO. Okay, correct. So this is the input, and this is the decision. Okay. So if you may put it the name of the module in each of the line, also very good okay. All the line you put calculate discount. So if you have 3, 4, 5, 6, 7, so put 7 Okay. Alright, and then display. Okay, display discount percentage. Okay, this is the module and this is the output. Okay, so this is inline. Inline. This one, and this one is in the same line. And finally, end and return to the control. This is supposed to be the same with this one, the main module. Okay, good. So if you are going to required to develop the algorithm, just copy and paste this, the same. So for flowchart, okay, so true. So this is what, class? This is by selection, by selection. Okay, good. Alright. Okay, good. This is also correct. But what you are missing over here, okay, if you put it like this, you are missing on the indent marks. Indent, this is supposed to be slightly to the right because it belong to this one. Okay, this is the parent. This is the child. So you need to slightly put it inside, meaning that this belong to this statement. Then goes to else. Okay. Okay, overall good. Any question, class? You're not going to see written test question like this, This is only for exercise,
Sir,
Okay, yeah.
if we write algorithm, do we need to letak nombor kat sebelah tu yang 1, 2, 3, 4, 5 tu?
Yes, it is a compulsory, compulsory to put down the numbers because later on, you might need this to construct the dash checking table. Dash checking, So lain tak ada dash checking, You're not required to. Ada? Tak ada?
Tak ada.
Tak ada. But this is compulsory, to put down the line numbers for algorithm. Okay. Any other question? Clear, Tak ada? Okay, tak ada. Then we proceed with part 2. Okay, multi-selection, Multi-selection. But this is how we write down. Okay. Multi-selection, we know multi-selection will involve more than one. If we are using if-else statement, for sure it will involve more than one diamond symbol, Multi-selection, the diamond symbol. This one, So it will involve more than one symbol. Okay. But the one that we used last week is the positive logic. So actually we have already covered this positive logic. This is not multiple decision. This is nested, nested decision. This is multi, and also multi. All is about multi-selection. Okay, but this is special. We have a condition inside of a condition, but not in the same sets condition. This one is all in the same sets. When we say about same sets of decision, okay, for example, if you have multi decision, okay, this is what we said as within the same sets. Okay, we are calculating the same things. Okay, P, okay, it is in the same sets. But when we talk about nested, nested is within a set, we have another set. Okay, that one is nested. Later on we discuss this. So let's focus on these three first. Okay, multi-selection within the same set. But we can write it either using straight true logic, positive logic, negative logic. The one that we already covered last week is mainly about the positive logic. Okay, when we talk about positive logic, okay, you should be clear that okay, we have two, true, and then we have false. Okay, so where should I put this one? True or false? True or false?
False.
Okay, correct, False, So if it is a positive logic, we always put the next decision in the false arrow. Okay, if it is a true, then we have another statement. Okay, the statement can be calculation, can be inputs, can be can be inputs, can be what? Can be Okay, can be another decision but not in the same set. Okay, for example, this one, but it is not in the same set of decision. Then we put it in true. Okay, true, this is true, this is true, this is false. This is true. So this is false. Okay, we put it over here only if it is not the same set of decision. If it is in this within the same sets of decision, we always put it in the false. So this is for positive logic. Alright. Okay, let's look at the straight through logic. Okay, positive logic we already covered. So straight through logic is the least optimum solution. Okay, the least optimum solution. So if you can avoid, please avoid using this one. Okay, it's not good for your program because there's a reason for that. Okay, so we are going to look at why it is not good to use straight through logic. Okay, straight through logic is using the sequential logic structure logic. Okay, although it is a decision, okay, it is using a sequential logic structure logic on the solution. Okay, for example, we have this. Okay, we have this problem. Okay, you need to calculate the fees. For entering a zoo so these are the condition. So over here so straight away we will know if you are using a standard decision. Okay, standard decision like we discussed last week So how many decision symbol that we must use, class? What is the input, class? Input is?
H.
Input is H. Okay, this one very easy So we need to have H so that we can create the decision So the first decision is?
H less than 16.
H less than 16.
Okay, good. Less than 16. Okay, so if this is true, what will happen? What will happen? If this is true?
Charge equal to 7.
Okay, good. Okay, good. Okay, it is good if you put it like this. Don't straight away print. It's not very good. If you straight away print, you are not going to have this value stored anywhere in the system. So we need to store this so that later on, let's say if we need this value again, we can recall it from the stored variable apa tadi? Fee for example, fee equal to 7. Okay, this is if it is true This is true True lah Okay, so okay, true. This is true So if it is false, what will happen?
We move on to H more equal to 16 and H less than 65.
Okay, good. So we are going to have another one over here. Okay. So make sure you write it correctly Okay, this one supposed to be you are supposed to use all the operator correctly don't put something like this is common mistake. Okay, you put something like this and then maybe some of you will write down like this. More than 16 less than 25. This is common mistake. If you put it up like this, you're not going to get full marks for this. Okay? Because it is not understandable by the computer. Put down the expression or equation that is understandable by the computer, class. That one you need to refer back on the expression and equation, the operator and everything. Okay, so understandable meaning that you need to put the formal operator, use the formal operator. So this is 2 kan. This is involving 2 expression kan. So if you put it like this, you are combining kan. So not acceptable. So use formal operator. If in this case it is already given to you, so it is very straightforward. Okay, most of the time, okay, it will going to be like this. 16 to 64. Each given to you is like this. So you need to create the expression. So if it is the case, it is in between 16 and 64. So how do you write down expression in between 16 and 64? Like this. Okay, this is meaning that it is in between 16 and 64. You get this, guys?
Yes.
You make sure you know how to convert this information to this expression. So this is what you put inside of a condition. All right. Okay, so if this is too big. Okay, if it is a false, we go here. Okay, if this is true, what will happen?
V equal to 10.
Okay, V equal to V equal to 10. Okay, so this is true. If it is false, what will happen? False, what will happen?
H more or equal than 65.
Do we need to add another decision?
No, V
No.
equal to 5. No.
Don't put another decision kan. So we already discussed it kan. So let's say we have 3 kan. 3 decision. Make sure you put 3 minus by 1. So the number of decision that you put in your design, either in the flowchart or algorithm, it should be minus 1. Okay, if there's a 5 decision, 5 minus 1, okay, the last decision you make it as a else. So this is else, the last false should be else. So this is else. Else no decision refer back to last week notes. Else no event. If there is a if, meaning you need to put decision. Since it is a else, it's always the statement for the false, the last false. So this is else. Else V equal to 5. Okay. Then we also already discussed last week. You need to make sure all the parts meet at one point. The meeting point should be independent. You don't put arrow from here to here kan. So that's going to replace the value kan. If you put it like this, it's going to replace value 7 with 10, which is wrong. Right? So make sure it is independently connected with each other. Alright.
Sir,
Yes.
saya tanya yang untuk second decision tree tu, kita boleh letak age lower than 65 saja ke?
This one also can. If you put age less than 65, also correct.
Okay, thank you, sir.
Okay. Either you put it like this, okay, showing the in between, or you put age less than 65, also correct. Okay, this is meeting over here. So this is the meeting point. Okay, then it will go to the next statement lah. Anything lah. For example, in this case, the statement is print and print the outputs. Okay, print the output over here. Ni lah sini. Print fee. Right. Okay, then at the start lah. Okay, at the start we have end. Alright, so this is what we call as the positive logic structure. Okay, normal structure that we use positive. Tunjuk juga ada juga yang nanti some of you, I don't know some of you, if you are not understand so please ask whether it is a simple question or not it's okay. So this is start, this is end Okay, so this is positive logic structure. So how you read it? Okay, it will skip it will skip the following decision if the decision is correct. Okay, for example, if you enter 5 over here so this is correct true so what mean by skip? Skip lah, it skip this one. Okay, the compiler will skip the next. If let's say we have 10 sets of decision. Okay, if this is correct in the first run, okay, user enter 5. So 5 already correct, true so it will skip the rest of the condition. Okay, and straight away go to print it doesn't check the rest. So this is the nature of positive logic structure. Okay, compared to straight through logic structure. Okay, straight through logic structure will check all the condition that you have in your design. So let's say if you have these two so it doesn't give any big difference because only two Okay, let's say this is a straight through logic. So straight through logic, okay, the flow is not going to be like this The flow is going to be like this. So this is, if it is true, you give a fee 7, it will re-enter the decision flow again. Okay, and to check this, although this is already true, it will check this again. Okay, go here, not print yet. Okay, not yet. It will, let's say if you have another one over here, it will re-enter the decision set again. Okay, and okay, it will looks like this slightly different. Okay, very different. So this one will go to the print over here and then print. then n. Okay, n over here. Okay, you see what's the problem, guys? Okay, imagine if you have 100 decision, 100 decision lah. For example, 100 decision, 1, 2, until 100, So although the condition for the first one already true, P already got the value 7, it will check again. Okay, false. We know it is false, kan? We know it is false. Sorry, this is not here. So it's supposed to be, oh sorry, I'm missing another one. Okay, sorry, I'm missing the last one, which is age more than 65. Okay, this is supposed to be here. Okay, this is the nature of the straight through logic. Apa ni? Okay. Okay, balik lah. Okay, this one, it will re-enter. Although it is true, we re-enter again. Okay. And then this one, it's true. Get the fee, RM5. RM5. Then it will, okay, it will go to print. This one false, nothing will happen. Okay, false, nothing will happen. Okay, so it will looks like this. It doesn't looks like the positive, positive logic. If you have 3 over here, okay, 3 minus by 1, we use only 2 decision symbol. Okay, but for straight through logic, if we have 3 sets, 3 decision, we put 3 symbol. Okay, because it need to check all the decision one by one. Okay, one by one, we check the decision. So for each of the decision, if it is false, okay, nothing will happen. It will re-enter the decision again. Okay, false, nothing will happen. It will re-enter again. Okay, you see, guys, the flow. You see the flow? If you enter 5 over here, okay, 5 true, P equal to 7. Okay, we got the fee already, but we need to re-enter again, check again. We know that it is false, and then false again, and finally we print 7. Okay, clear? Positive. Straight through logic. Sorry, straight through logic. Any question? Straight through logic. So when the steps, okay, when the steps and the running steps increase, so do the time taken to execute this program. That's why compared to the positive logic structure, this program, this type of design is going to require your program to running with more time lah, because it will read all the decision involved in the design, which is not good. That's the reason why if you can avoid of using straight through logic, please avoid. Ni cantik sikit lah lukis. Okay. Okay. The same thing, right? What I already shows. Alright. In terms of algorithm, also is slightly different. You see, it's like it is very independent. Independent with each other. Okay, although it is in the same sets of decision, for each of the condition, you need to put an if. Okay, it treat this as independent. That's why if and if and if. So this is like the single selection. Okay, the combination of single selection, although it is a multi-selection, it is a combination of single selection. Okay, on how you write down the design. Boleh kelas? Anybody confused with the straight through logic? Boleh eh? Okay, so positive logic. Okay, we're done with this. The the statements for positive logics, we always put it in the true branch. For the false, if it is false, it always enter another decision. Until the end, of course, the end, if it is else, then it will have its own statement. So this is the same thing. Okay, the same thing. Okay, this is what we already discussed last week. Okay, if it is a true, then it will have its statement. Okay, if it is true, then it have its statement. Then when it is false, this is false, and we have the statement for false. Okay, so this is the same thing that I draw earlier. Positive logic, if it is true, it has statement. If it is false, it enter another decision. So this is the else. The last one, else. So we use only 2 diamond symbol instead of 3. Boleh? Positif Okay, negative. Negative is rarely we use this because it's quite confusing. The condition that we put inside of negative logic is actually the opposite of positive. You see, the condition is the flow of the processing continues through the module when the resultant of the decision is false. When it true, it enter another decision. It vice opposite to the positive. If positive, if it is false, it go to the another decision. If it is true, it will have the statement. So this is opposite of positive logic. Okay, so we use the same example. Okay, now we write it in the form of negative logic. You will see that you will get, let's look at the flowchart first. Okay, the flowchart is like this. Okay, if it is false, it will have statements. Okay, if positive, false, we have statement. True, we have statement, and false, we go to another decision. But this is opposite. Okay, if it is true, it will re-enter the next decision. Okay, that's the difference. But make sure you check the condition. The condition is not the same like positive logic. So positive logic, you see, okay, let's copy paste this one. Where is it? Positive. Put it side by side. Susah pula. This is positive. Can you spot the difference, class? You see the condition used over here. It changed.
Yes.
Okay. The first condition is not the original condition. You need to change this in order for you to use negative logic. Okay. You need to change this. Okay. From here, less than 16. If you put less than 16 over here, your logic is going to be wrong. Okay. If it is less than 16, if it is false, we will not get charge equal to 7. It's going to be different. Betul? Because it's supposed to be true. Less than 16 is supposed to be true. So you need to change this. So how to change this? Okay, how to change this? There's a formula for this. Formula how to convert positive to negative, which is using this table over here. Okay, let me copy this table. Positive to logic conversion. Okay. Put it over here. Okay. So now we have positive less than 16. So if you want to convert it to negative logic structure, less than. Okay. So the new operator that you need to use is more than or equal. You see, less than. If you want to convert to negative logic, it is more than or equal. Of course, this one should be false. This is should be false. This is true. This should be false. If true, it will enter the next decision. So this one, originally, it is less than 65. Okay. So when you want to convert it, less than, now it become more than. It's supposed to be more than ni kan? More than. Ni more than ni. Less than. More than. More than 65. Okay, more than. Sekejap. Ni apa ada ni? I think this is based on situation. I think it's supposed to be more than, equal, something like this. The same. So it says the same. So more than or equal. Okay. So this you need to choose this one. Based on the situation of your problem lah. So in this case, it is much more. It is correct if you use this one. Okay. Alright, so this is the symbol. Okay, this is the original operator. And this is when you want to convert it into negative logic. Okay, you choose this operator. Alright, so this is negative logic structure. And of course, when we look at the algorithm, the algorithm is going to be like this. You see, there's a if this is true. So if this is true, you will enter another if. Okay. So this is equal with this one. If this is true, you will enter another if. Okay. If this is true, you will enter another if. Okay. Decision will give you a statement only if it is true. Okay, remember that. If there's a decision, if there's a condition, we only put the statement if this is true. That's why over here, when this is true, we put it over here. This is false. The false is over here. So this else belong to this. Okay, this else belong to this if. That's why indent is very important. Okay, so this charge 7 is over here lah. This is the else. Okay, this is else for this one. Charge 7. Okay, this is charge 7. Kena saya letak side by side juga. Okay, side by side and you can compare. Okay, let me remove this first. Okay. Okay, compared to this one, this is what we used last week. This is normal. Alright, you see, if this one true, it will enter the next. So this statement over here, this decision belong to this. So this is a child for this. That's why we put it indent. This is the child. All the statement over here is the child of this statement. True, kan? This one, if this one is false, if this is one is false, charge equal to 7. Okay, if this one is false, so this is the false statement. Else, kan? Else is for false statement. Charge 7. Over here is normal, kan? Normal we do inside of this. If this is true, charge 5. If this is false, charge 10, kan? False, charge 10. Okay, class. So what if we have more over here? If there is true, let's say we have another one over here. Whatever the condition whatever the condition I didn't put the condition XS So what will this looks like? For example, this one, if true, charge 5. If false, charge 6. This is true. This is true. Over here, over here. So how the algorithms going to looks like, class? Let me copy the algorithm. Alamak, pening Macam ni pula jadi. Macam mana, kelas? So how's the algorithms? Okay, look at this. So let's modify the algorithm. Algorithm, this one, if this is true. So where we want to add this one? If x, where should I put it? Okay, let's say this is line number 1, 2. Pula nak edit sini. This is line 1, line 2, line 3, line 4, line 5, line 6, line 7. So where should I put the new decision? In line? In line what, class?
3.
In line 3. Line 3 here. Okay. Line 3. Is it correct? Correct. Okay. This is true kan? True. You got this one. This one. So if this is true, you got another decision. Correct. So in line 3, 1, 2. In line 3, we have slightly to the right. Slightly to the right because it belongs to this one. It belongs to this true. True meaning it belong to this. Okay, so we add if and if whatever the condition and then what? If it is true, then what? Then what, class? If it is true,
Charge 5.
Equal to 5.
should I put it slightly to the right?
Yes.
Slightly to the right, okay? Because this belong to this condition. Okay, because it is true, meaning that it belongs to this condition. So you need to slightly to the right. Alright? And then this else belong to which one? Charge 10. So this else belong to this. So you need to trace this first. Okay, this is else for this one. So it need to be in line. Okay, so charge equal to
6.
correct. Charge equal to 6. Over here, 6. For this one, how do you write this? How do you write this? This is line 1, 2, 3, 4, 5, 6, 7, 8. Line what? Line number? Line number what, class?
7.
Line number 7. Okay. So have a look at this one. Okay, so this is over here. So this is all if it is true. But if it is false, okay, so we have this one, in line, the same line. The same line. Of course, this one you need to put an if first. So this is an if lah. Okay, and if. So this one, and then the charge is 10. Okay, slightly to the right. Charge is 10. Okay, this is the false. So this is in same line with this one. Indent is very important. Okay, and lastly, we look at this one, okay? This is belong to this one. Okay, this one belong to this end. So it's supposed to be formally we need to put an if for each of the and if, and then lastly we have the else ni kan. The last else belong to h more than equal to 6. Okay, so this is h equal to 7. And if ni, and if tengok balik lah. Kena tulis and if. Okay? Okay class?
Okay.
You see the flow If this is true, it enter this one. If this is true, it enter this one. Okay, if this is true, it enter this one. If this is true, it enter this one. If this is true, it give the charge. Okay, you see, if this is true, it give the charge. If this is false, it give the charge. False, give the charge. Okay, so this is how you write negative logic structure, which somehow for me it's quite confusing. So don't have to use it. Okay, same like straight to logic. If you can avoid, please avoid using this one unless the question asks you, okay, the question specifically asks you to use negative logic structure. So you cannot avoid, right? So you need to use it. So you need to know how, but if you may avoid, please avoid. Okay, so this is negative logic structure. Okay, how to write it? Okay, clear? Any question before we move on to the nested?
Sir,
Yeah.
in the exercise or test, the question will ask either we will use the negative logic, positive logic or multiple. Sama ada dia akan disuruh guna negatif or positif. Ada.
Okay. Based on I cannot say that the question will mention that lah. Based on question, okay. Sometimes the question specifically asks you to use which kind of logic. Then you need to follow the question lah. The question asks you to use specifically mention you need to use negative logic structure to design your solution. Then you need to use negative logic structure. If you use positive, then your answer is going to be wrong. Okay. But if let's say the question doesn't mention, okay, doesn't mention any negative, positive, or straight to logic, so it's up to you. Okay, you may write down negative, positive, or straight to logic. It's up to you. But the best way is to use positive lah. Always use positive if the question doesn't mention any logic specifically. Okay.
Okay, sir.
Okay, so this is a conclusion the conclusion of the comparison straight through, positive and negative. Okay, this is in terms of general general design general. Okay, general, positive, you see. Positive and logic, we minus 1 the condition we minus by 1 the condition, whereby the straight to logic we put all the condition in the design, which is not good. Okay. Okay. So next we move on to the nested. This is of course multiple but specifically is nested. Okay, nested. Nested if then else statement. Why we say nested? Because in our design, sometimes we need to put a decision within a decision. For example, this is, I think, the question we already used this earlier. Boleh tak? Not here. Where is the question? Suddenly got answer only. Later on, I will give you partial question. That one cover everything. Cover the negative logic, positive logic, and also nested. You try to do it first, and then we are going to discuss during the lab. This is how to convert lah. Okay, this one multiple decision. Let's say if the question mention you like this in each of the main decision, you need to include another sets of decision. This is belong this one. If you see the indent, this one belong to this. Okay. Okay, sorry, this one supposed to be over here. Don't get confused. Okay. If you see something like this, okay, this is what we call as nested decision. Okay, we have two sets of decision. The second set decision resides within the first set of decision. Okay, so this is nested inside of decision. Okay, inside of decision, we have another decision. Actually, if you look at this, it is similar with which logic class? Positive, negative, or straight to logic class? The structure. Similar with what? Positive?
Positive.
Positive. Are you sure? Positive. Is it similar with positive? Let's look at positive. Positive. This is positive. Is it similar with positive? Algorithm ada algorithm. This is positive. Is it similar? Are you sure?
No.
Similar with what?
No.
It's quite similar with
Negative.
okay, it's similar with negative logic structure in terms of the structure only, not the condition. This one, you see, in a negative, we have decision inside of decision. This is considered as nested class. So if you are using negative, actually you are complicating your design to use the nested. Not all solution to a problem you need to use nested. So if you can avoid, you may avoid nested. But if you're using negative logic structure, straight away you are actually applying nested design to your solution. If you are using positive, you see it is independent. Not independent. It is it doesn't have nested no condition, no decision inside of decision. But negative, you have it. Okay, so nested is quite similar with the negative logic structure. Okay. All right. So this is just a brief introduction to the nested. Okay. In order for you to know when to use it, you need to do the exercise first. So this is the flowchart, you see this is if, and if this is true, we have another sets of decision. This is not the same sets. So make sure you know. So this is not the same set. This is for pay type, and so this is for hours. Okay, so not the same. The same meaning this is hours, this is hours. That one the same. Okay, the same sets. So this is different sets, which is this one. Hours is inside of part type decision. Alright, so that's it for the explanation. Okay, the rest is, this one I already covered this one. How to convert the positive to negative using the table, this table. Alright, so we have about 45 minutes left. I really want you to do the past year question so that next week we have midterm test on Monday, class. So that we can discuss the answer during this week lab. So this is the question. Midterm test ni. This is a real question of midterm test. Okay, as you can see over here, the midterm test can have one question or more than one question. So in this case, your senior is quite unlucky to have more than one question. So take a look at the question. Okay, answer all question. Okay, answer all question and apply. For example, this one, question 2, you see, got positive, got negative. So you need to follow. Okay, answer all question and submit through Kalam before lab. Okay, before lab this Friday. So you need to answer and submit before Thursday midnight. Boleh guys?
Boleh, sir.
Boleh, sir.
Okay, hopefully by doing this exercise, you get better view of what you are going to have in the midterm test next week. Alright. Okay, let me